So let's talk through some different methods of graphing quadratic equations and things to look for and some tips and tricks that we can use. So we have our equation right here, y equals -1/2 times x minus 6 squared plus 4. So what we could do is go through and get our kind of key features here. So something I'm going to notice is that a is -1/2. So with that, I already know we're opening downward. I can also go ahead and get the vertex directly from this format with h of +6 and a k of +4. And then we could go through and solve for some intercepts. So I could get our y-intercept by plugging in x equals 0. So y equals -1/2. 0 minus 6 squared plus 4. So y equals -1/2 times 36 plus 4. So a -18 plus 4, so -14. All right, so I have the coordinate 0, -14. And then for x-intercepts, I'm going to solve 0 equals -1/2 x minus 6 squared plus 4. I'm going to subtract 4 from both sides. To take care of that -1/2, I'm going to multiply both sides by a -2. So I'm multiplying by the reciprocal so that we have +8 equals a -2 times a -1/2 is just a +1. Then I can take the square root of both sides. So x minus 6 is equal to plus or minus √8. Adding 6 to both sides, I'm going to have x equals 6 plus or minus √8. And because I'm graphing here, I'm going to go ahead and get the decimal approximations for those so that I can graph them. So that should be an 8.83 and a 3.17. Okay, so that gives me quite a few coordinates to graph. And let me just write those in coordinate form so we can see the points that we have. Okay, so with that, let's see, I'm going to need to see down to -14 on the y-axis. So I'm thinking I'm going to need a scale of 2 there, but I could keep a scale of 1 along the x-axis. That should work out fine. So I have the coordinate 6, +4. So I'm going to go 3, 6, 2, 4. And 0, -14. So 0, 2, 4, 6, 8, 10, 12, 14. And then 8.830. So 1, 2, 3, 4, 5, 6, 7, 8. And then about 0.83. And then 3.17 is about right here. I can use some symmetry here. So 1, 2, 3, 4, 5, 6. Oh, I'm not going to see far. Oh, actually, it's perfect. 3, 6. Cool. Okay. So that gives us our parabola right here. Fantastic. So we can get the parabola by just going through and grabbing our pieces of information and graphing the points. Something I want to do is show you another method here. So with this, what we can do is talk about our general format of a parabola. And actually, I'm going to go ahead and switch this to a scale of 1 here just for this conversation. So a general parabola, the vertex is at 0, 0. And then as we go, let's look to the right. If I go to the right 1, I would go up 1 because that's 1 squared. If I go to the right 2, I would go up 4 for 2 squared. If I go to the right 3, I would go up 9 for 3 squared, like that. And then we have the same thing on the other side. So that is my general parabola that opens upward. Opening downward is the same idea, just in the other direction. So if I go right 1, I would go down 1, right 2, down 4, right 3, down 9. Like that. So similar pieces. Now, we know our parabola is opening downward because of that -1/2. Because a is negative, we know we have this format. So let's talk about what that 1/2 is doing to our outputs. So if this is how it usually looks, kind of, ooh, that got a little wobbly, but we're all good. What that value of 1/2 is going to do is it's going to cut those y values in half. So where I usually go to the right one, down 1, I would go to the right one, down 1/2. Where I would usually go to the right 2 and go down 4, now I would go down 2. Where I'd usually go down 9 units, now I would go down 4.5 units. And that adjusts the shape of our parabola to fit that -1/2 value. So another way, using that idea to graph the parabola, let me erase those pieces, is with that vertex form. We know our vertex is at 6, 4. So I could go 3, 6, and then up 4. So we have our vertex right there. And I know the parabola opens downward, so we'd usually go 1, 1, 2, 4, like this, and then 3, 9. So I'm just going away from the vertex. So 1, 1, 2, 4, 3, and then I could go 9. But because it's 1/2, I would go half the distance. So going a distance of 1/2 instead of 1, and going a distance of 2 instead of 4, and going a distance of 4.5 instead of 9. And that right there gives us the same shape we were seeing. It might look a little different because I did adjust the scale just for the sake of seeing those 1s, 2s, 4s, and 9s. But it ends up giving us the same graph. So all I really used there was the fact that we had a vertex at 6, 4, and that a is equal to -1/2. I just used those two pieces of information to make our graph. And look, that looks like our 3.17 and our 8.83. So we're totally on track here. And we could just use that. This is kind of a graph transformation of how this is changing those vertical distances, in this case by 1/2. And then the negative just tells me that we're going downward. Okay, so let's talk about, if we're given a graph, how can we make the quadratic equation? Now, I kind of go and look at the x-intercepts first, because if those are nice, I might go ahead and use the factored form, but that's not the case here. So instead, I'm going to focus on vertex form. So that's the coordinate 1, 7. So I would have y equals, I don't know what a is yet, but I would have x minus 1 squared plus 7. Now to figure out a, there's a few ways to go about that. I could use the method I was just talking about. So just kind of mapping, let's say I go to the right 1, well, I'm going down 1. I like that. Going to the right 2, I'm going down 1, 2, 3, 4. Okay. So what that's telling me is that our y distances haven't changed. So I'm thinking a value of 1 for a. Then my parabola is opening downward, so that should be a -1. So we are going to have y equals negative x minus 1 squared plus 7. And that'll be our answer. Another way you could go about this is plugging in a coordinate. Like I'm seeing this coordinate of 0, 6. So what we could do is, if we have this y equals a times x minus 1 squared plus 7, I could plug in y equals 6, x equals 0, which would be 6 equals a plus 7, subtract 7 from both sides to solve for that value of a. So two methods to accomplish the same thing, either with kind of graph transformations or plugging in a coordinate to solve. Let's do another example here. So again, I'm going to focus on our vertex is -4, -6. So we're going to have the format y equals a x plus 4 squared minus 6. And then what I could do is the kind of mapping. So I'm seeing, okay, if I go over 1, that looks like I'm about halfway. If I go over 2, we're going up 2 instead of 4. So what I'm seeing is everything's being cut in half. If I go over 3, I'm going to have 1, 2, 3, 4, 0.5. And we're opening upwards, so A should be positive. So I'm thinking we have y equals positive 1/2 x plus 4 squared minus 6. And we could check that by plugging in a coordinate that is not our vertex, like that coordinate 0, 2. I could go 2 equals a times 0 plus 4 squared minus 6, which will be, I'm going to add 6 to both sides, so 8 equals 16a, divide by 16, and there's our positive 1/2. So that's how we can work with our vertex form to either find the equation of the quadratic or graphing the quadratic.